our information, do you have any timeline, like how long the presentation will last?
I think we'll be about an hour.
All right, that's perfect. All right, great, fantastic. All right, shall we start?
Sure.
All right, so welcome and hello, everybody. This is another presentation that is part of the Language Technology and Data Analysis Laboratory Webinar Series 2021, the LADAL Webinar Series 2021. Because LADAL is sponsored and has been established by the University of Queensland in Australia, we'd like to acknowledge the traditional owners and their custodianship on the lands on which we meet, which are the lands of the University of Queensland. We pay our respects to the ancestors and their descendants of the traditional owners and the custodians of the lands who continue cultural and spiritual connections to country. We recognize their valuable contributions to Australian and global society. If you'd like to know more about the Language Technology and Data Analysis Lab, please visit our website, which is hosted by GitHub. If you would like to know more about the webinar series, upcoming events, speakers, and abstracts, please visit the LADAL Opening Webinar Series website. You can also follow us on Twitter to be alerted of upcoming talks, and you can contact us anytime using slcladal@uq.edu.au. Now, it's a real pleasure of mine to introduce three really fantastic speakers. The first speaker is Vincent DeLuca. Vincent is Associate Professor and Co-Director of the Psycholinguistics of Language Representation Lab, the POLAR Lab, which is part of the Aqua Aurora Center, the Acquisition, Variation and Attrition Center at the University of Norway, the Arctic University of Norway, UIT. His research is focused on how different aspects of bilingual language experience variably impact brain structure, function, and cognitive processes. He is particularly interested in how these neural and cognitive adaptations dynamically shift over time and with patterns of language use. The second speaker of today's talk is Thomas Voits. Thomas is a postdoctoral researcher at UIT, and he's also affiliated with the Polar Lab and the Aqua Aurora Center. His work is primarily focused on investigating the effects of bilingualism on neurocognition, with a particular interest in examining bilingualism as a contributing factor to cognitive and brain reserves in later years of life. Last but not least, Jason Rothman. Jason is Professor of Linguistics at UIT and Deputy Director of the Aqua Aurora Center, where he co-leads the center's theme on the neurocognition of bilingualism. He co-directs the Polar Lab, and as a linguist by training, he has worked extensively on language acquisition, linguistic processing, and language-associated links to domain general neurocognition across the lifespan of various types of bi- and multilingual populations. He is founding editor of the journal Linguistic Approaches to Bilingualism and executive editor of the book series Studies in Bilingualism. I'd like to welcome the speakers, and I'd like to hand over to them and their talk, Neurocognitive Effects of Bilingual Experience.
All right, thank you very much, Martin, for that. That was great. I'm going to now share. Can everybody see my screen? Is that, yeah. Okay, let me do this and then we'll get started. Okay, so now that the technical issues are out of the way, they always make me very nervous. I feel good, and let me really properly thank you also for the invitation. It's really a pleasure to be here. It's very nice to be back in Australia. Maybe in the future, it'll be a real back in Australia. You guys are doing ISB actually in 2 years, so we're all already planning to come back. So also I notice, we're a relatively intimate group. So let me say too, that if you have a very pressing question, just, put your microphone on, especially if it's clarification, and you can ask throughout. Will be about an hour. And today we're going to go over a bunch of work that we have been doing mostly together in various cohorts. regarding neurocognitive effects and neuroanatomical effects, in fact, on the bilingual brain by virtue of experience. Okay, so let me give you a little bit of a roadmap because we're going to play some musical chairs today. I'll start and I'll give you a little bit about the context of bilingualism. It's not intended to infantilize anybody. Probably everybody here works or thinks about bilingualism, but we'll just make sure we're on the same page. I'll then turn over to Vince and he'll talk about bilingualism and the brain in general, and neurocognitive models and methods, as well as some previous work. He'll share that with Thomas, who'll then come to talk to you a little bit about our work, particularly in older populations. And then I will come back to talk to you about where we are going from here, both us and then just future directions. Okay, so to get started, what is a bilingual? Okay, so that's a loaded question, actually, as most of you should know. I'm going to suggest to you that a bilingual is many things at the same time, right? So, but there's a common core. An individual who has knowledge, a mental representation of at least two languages, or two languages if you want to be precise and say bi versus multilingual, for the purposes of understanding and or speaking these languages, right? We know that bilinguals can be passively completely proficient and fluid, but seemingly have difficulties or maybe even at least perceive that they can't say much of anything at all. But of course, if you want to know what it's really like to be monolingual or to not know a language, I could start to speak Hebrew to you right now. And my guess is many of you would have really no knowledge whatsoever, right? Okay, so native bilinguals are those that have two native languages, often called 2L1ers or simultaneous bilinguals. I stress the word native, right? Because sometimes we confuse dominance with the word native, right? So a heritage speaker, which I, Irina, and other people who are here work on quite prolifically, they are native speakers of their language, even if they don't show dominance in what was either their only first language or a language they share natively in terms of naturalistic early childhood acquisition. Some bilinguals, of course, become later in life, sequential bilinguals. After the age of 4 and beyond, a person is considered a second language bilingual, but of course, not all are the same. Child second language learners, especially in an immersion or naturalistic context, often present very differently and potentially are even heritage speakers of and become dominant in a different language from the one that they were potentially exclusively exposed to when they were children. So bilingualism and its extralinguistic outcomes are a spectrum, right? And I have really just scratched the surface of all the areas that sit between these two potentially very recognizable descriptions of a sharp difference between types of bilinguals. There really is potentially dozens, if not many, many dozens or hundreds of individual contexts that you could say are a type of bilingual. Skills and opportunities for use of language can vary on a rather wide spectrum, from receptive understanding, which I mentioned before, to full, whatever that means, let's put that in quotes, production comprehension abilities. Many extralinguistic factors limit exposure to, need, and desire for using one or the other language, or both in the case of code switching. And actually, one of the things that we'll do is we're going to capitalize this, and we tend to do this over the past couple of years in our research to really unpack and regress these spectral differences of experience and engagement with experience to understand outcomes as they exist on an equally wide continuum. Okay. And now I can't move. There we go. Okay, so let's talk a little bit about bilingualism in a global and national and local context, right? So first of all, we all know this, right? Multilingualism is the default state in the global context. That's something that maybe in Australia is perceivable in a way that's different from where I grew up. I grew up in the United States, where bilingualism is commonly taken to be exceptional, right? But we know that it's not exceptional. And of course, in certain contexts, even within so-called monolingual countries, this exceptionalism really just fails to equate to the reality that you can see around you. But of course, you could be, so maybe if you're in the middle of Los Angeles, that to say that it's the default state makes perfect sense, whether or not you are a bilingual, but maybe in the middle of rural Idaho, that seems quite exceptional to say, okay? Over 50% of the world's population is bi-multilingual. Many naturalistic children by multilinguals in the global north, right? So 1 in 5, and by the global north, I'm really referring to what most people lay people in the context would say are, quote, monolingual societies. You still have 1 in 5, and many more in the global south, making estimates already roughly 50% in children alone, okay? In places like Africa and Asia, for example, societal multilingualism is very apparently the default norm. So if you take a country like Malaysia, for example, where there's 4 national languages and many, like in all contexts, heritage languages, you'd probably be hard pressed to find somebody who speaks or has comprehensive knowledge of just one language. Okay, let's go to these graphs that are on the side. The first one on the top is taken from Marion and Shook, a paper in 2012, and it schematizes. So the numbers, because this is from 2012, it's based on the 2006 European Commission's report called Europeans and Their Languages, and it's probably shifted a little bit, but it makes the point nonetheless. So in 2006, the European Union reported bilingualism at a rate of 56%. That's 44% so-called monolinguals, but this is not equally distributed. And one of the reasons why I like this graph is because it shows how this distribution is really skewed, right? So if we're talking about to get to the number, or to get to the proportion of 56, when you look at individual composite countries and their relative reporting, so Luxembourg is basically everybody is at least bilingual with 2 languages. The Netherlands reports at 91%, Germany 67%, Poland is right around that average at 57%. There's some things we can take from this. Norway is actually quite high. It wasn't originally there, but I wouldn't be surprised if it's much like Sweden, if not between Sweden and Denmark in terms of the reporting. Now, a question can be, well, how are they reporting this? This is not naturalistic bilinguals. This is not that 97% of Sweden speak a home language, and in addition to Swedish, English is kind of really lurking here in terms of boosting these numbers. And how a country reports this can depend on how the country either asks the question or perceives of this. But the point is that the perception of the population is that they are very proficient in more than one language in this context. Now, how do we get to 56% in the entirety of the European Union if we have countries reporting at 97%? Well, the most obvious thing is that Germany's proportion of 67 is weighted against 80 million people versus Sweden's, which is only 9 million people, or Luxembourg, which is fewer than 500,000 people. But you also have contexts in which countries really don't come anywhere close to this 56%. If we were live, I would ask you to shout out, can you guess what some of those countries are? And you would probably be right if you were to shout out the United Kingdom, Ireland, and of course, other countries that bring this average kind of down. So the one good thing about Brexit is that these numbers are sure to rise once that is officially done, and the UK. I'm of course joking. Well, yes and no, I'm joking. It's a reality that will happen. But even in the context of the UK, and I'm not going to give you numbers, bilingualism is really prevalent and especially important for the educational system and young children. Okay, but let me move over to the context of the United States, because I'm going to take what a lot of people say or think, especially within its own context, is a monolingual country. And again, these are relatively older numbers. If we were to look, we would see that in the 2016 and beyond census, we're well over 20%. But just looking at 2007, there was roughly 20% reported bilingualism in the context of the United States. Now, much of this is actually not second language learning, right, as would be reported differently in the European context. And what the point here, what I want to make is to say that, yes, it's 20%. And you could look at that as, of course, that's extremely important, right? 20% of such a large population is many, many people. And that's what I want to highlight. 20% of the US population is in excess of 60 million people. Okay, so just keep that in mind. And according to the National Center for Education Statistics in the United States, and this is actually quite recent, more than 1 in 5 school-age children, or 21%, speak a language other than English at home in the United States. And while this is skewed towards a particular language pairing, Spanish and English, of course, it's not exclusive to that, right? So understanding bilingualism and the many implications that bilingualism can have, be it for education, be it for health, be it for multiple things within society, is an imperative no matter where you are, even in these so-called monolingual contexts. Okay. And why can't I move forward again? Okay, here we go. Okay, so let's start to get into the background of what we're going to talk about today. We're not going to talk about all the implications of bilingualism, but in particular, bilingualism and its potential effects on neurocognition, be that in performance, and neuroanatomical changes potentially to the brain. Okay, and so what we see kind of here schematizes the general kind of approach, right? Specific connections between bilingualism and neurocognitive adaptations. First of all, we want to acknowledge that they're not yet well understood. That shouldn't be such a problem, right? Many things that have been studied for centuries are not particularly well understood, but we know that there is something there to be studied. So the general idea works like this. Obviously, if you have more than one language exists. It exists in many forms, but it certainly exists with an ecological reality in the mind/brain, right? And the idea here is that the existence of this and the management between these two systems to be able to use them efficiently and effectively creates competition. That competition has to have some level of resolution, and that resolution potentially has consequences or knock-on effects that we call adaptations, right? We're going to try to be neutral in our terminology here and not call them benefits and all of this, but indeed just resolved issues of this competition seem to relate to adaptation. And we're going to focus primarily today on things that we can't really argue about because they are physiological and we can actually measure and see them. And so I'm talking about neuroanatomical changes to the brain. I don't know why I'm having trouble moving this. Okay, so bilingualism in the brain, Vince is going to go into much more detail here, but in a general sense, learning and using more than one language does affect brain function and aspects of cognition, at least under certain conditions. It certainly creates a context in which the brain physiologically adapts to the context of the mental exercising of using more than one brain. Of course, we should acknowledge that extension and coverage of this, and I put it in quotes because I don't like the term anyway, bilingual advantage, especially related to executive function, task performance, has been the source of contention, some serious debate, replication issues. Of course, we understand this. We're going to shift away from that today. You can ask us about it because in all of these studies, there is a cognitive aspect. We're not going to talk about most of it. Studies show that bilingualism affects the structure of the brain. And again, we can measure this and we'll show you the functional connectivity of the brain. So again, this is something we can see in a physiological sense, and neural recruitment, and that is in task performance, okay? So not necessarily, well, potentially for executive function, but also language processing. We can see that the brain is processing the information in a different way relative to, let's say, efficiencies, okay? We'll come back to that, and I'm going to now concede over to Vince, and I will see you at the end of the talk. Thanks.
All right. Thanks very much, Jason. So as you mentioned, we're going to kind of shift course and bring you some background on kind of what we think we know about how the brain is adapting to bilingualism, as Jason very nicely laid out, kind of the mechanism by which this is supposed to happen. Now, the key point here is that sort of variability that we kind of talked about with the sheer number of bilinguals in the world and the potential variability in language experience that exists between them. It's unlikely that the same process of adaptation would actually happen for every single bilingual. And that's exactly kind of what has been happening in the field in recent years, is that several models have been put forward that try to capture different aspects of bilingual experience and make some kind of key predictions as to how the brain might actually go about adapting to these respectively. Now, I'm going to give you a quick overview of each of these. I'm not going to get into the exact predictions of each, but it should give you a flavor of kind of what the models are all getting at. So a couple of models, and you probably will have actually heard of several of these, take the position of specific communicative contexts and or the intensity by which one engages within them, for notably the adaptive control hypothesis that takes the position that situations where potentially only one language is available, where two languages are available, but you might only use one, or two languages available and you have the ability to use both, are going to necessitate different brain regions and neural networks, and crucially also cognitive processes, to best handle the management of those two systems, as Jason alluded to earlier, to best communicate in those contexts. Now, the act of engaging in each of those is going to reinforce those structures and networks, and is going to cause the brain to shift accordingly so it can most effectively and then ideally efficiently handle these. Now, some other of these models don't take the same sort of communicative context approach, but take it more from a trajectory-based standpoint. Notably, these two models on the right, they take the position of more how the brain goes from initially managing these systems to moving to a position of efficiency. And what you see here is that initial contact comes in more of these frontal regions of the brain. And I will clarify what I mean by all of this in a minute, just so we're all on the same page. But the idea here is that shifts, the regions that are recruited shift towards regions that we know are more involved in automation and efficiency. And I want to have us keep that in mind, because that's going to help sort of unpack some of the results that we're going to talk about kind of in due course through this talk. But again, just to wrap it up, there seems to be some specificity of effects predicted by the models, and these all seem pretty heavily dependent on the type of experience and the degree to which you engage with it. Now, I'm going to give you a quick recap of neuroanatomy and some of the methods we're going to talk about today. Again, not meant to infantilize anyone, just want to make sure that everybody's on the same page so we can all best understand the results we'll present to you. As we know, the brain is comprised heavily of neurons, the dendrites and axon terminals of which, the two endpoints, if you will, form what's called the gray matter of the brain, which you can see in the cortical and some of the subcortical regions. And then, of course, the tracks that connect them form what are called the white matter of the brain. That's notably because there's a layer of myelin, which is a fatty layer that surrounds it. And you can think of the myelin like the insulation on an electrical wire. The better structured it is, the more efficiently communication can happen between regions. Now, the key thing here is that all of these regions are used to variably to handle specific tasks, both in some form or combination. Now, when you have to do a task again and again and again, it's thought that the increased use of the brain regions used to do that lead to more gray matter, and that to handle the processing load. Similarly, more communication between those regions is thought to lead to more myelination, again, for faster and more efficient communications, and that would increase or otherwise change the white matter structure of the brain. Now, you'll note that I've put asterisks here, and that's because this is a dynamic process. More is not always better. In fact, we've often seen that changes can actually happen in the opposite direction. And we'll speak to, and that's an important point to keep in mind as we present some of the results we're going to today. Quick bit of background as well, just in case any of you are not familiar or have been fortunate enough not to have to potentially go into a hospital to receive one of these. A lot of the research we'll be talking about involves MRI to collect our data. And there's 3 scan types that are going to come up today, that all of which give slightly different information about the brain. One of which, the first of which we'll talk about, is a structural scan. So this is a high resolution 3D image of the brain, and that tends to be used to look at patterns or differences in shape and or size, volume, if you will, of specific brain structures and or regions. Another one we'll talk about is diffusion weighted scanning, which can provide us an indirect measure of the nature and degree of white matter structure in these tracks by measuring water flow. You can think of that as sort of the volume and or speed of traffic on a highway, and you can use that information to make some inferences about white matter and how it is structured. Finally, we'll discuss some functional scanning, which uses measures of cerebral blood flow to identify patterns of brain recruitment and or potentially networks in both at rest and in task-related performance. Okay, so with that all in mind, can get to some findings from our lab previously. And one of the ones I want to kick us off with is kind of an earlier study that we've run looking at one specific language experience, notably language immersion, and what it does to the brain over time. So again, this is from a longitudinal perspective. So again, the study aims were to assess the sort of longer term effects of linguistic immersion on brain structure and function. A bit of background, a lot of studies up to this point have looked at the effects of language learning on the brain, but it was to that point relatively less studied. What happens once you've got the languages and are using them continuously? What happens later on once you kind of reach more peak efficiency? That's kind of foreshadowing here. So to look at this, we scanned some bilingual adults, all of whom were living in the United Kingdom at the times of testing, and learned English in late childhood and then moved to the United Kingdom sometime thereafter. The procedure generally was as follows: 2 scanning sessions with approximately a 3-year interval in between them. Gave them a variety of scans, just as the ones we've talked about, and a background measure of an English proficiency test, specifically the Oxford QPT, to see if their English proficiency changed at all during this time period. Now, the English proficiency for these participants during this time didn't change, and though there might be several reasons for that, which we can discuss in Q&A if you're interested. But we did see several really kind of interesting brain structure adaptations that really nicely sort of paint some pictures about what these adaptations look like over time towards efficiency. Notably, gray matter volume increase in the lower right cerebellum and a mean diffusivity increase in left forceps minor. What does this mean? Recall from our overview of neuroanatomy and physiology, volumetric increases tend to mean a greater reliance on the specific structure. What do we know about the cerebellum? If we're seeing increases there, we know it's involved in a lot of automation and efficiency for cognitive processes. Similarly, this mean diffusivity increase would imply that the myelination in that structure is decreasing slightly. So we're looking at less communication or less reliance on these frontal regions. So over this 3-year period, what we're seeing is a shift in reliance from the front of the brain, which is more involved in those really cognitively demanding tasks, shifting towards more of an efficient use of these management of an automatic use of these 2 systems. That combined with some reshaping within the subcortical structures gives this idea of that shift to automation and efficiency with that prolonged intensive exposure. Moreover, the change in the cerebellum was actually predicted by the participants' age of acquisition and immersion, both of which point to more exposure and/or experience prior to that first scanning session predicted a greater amount of change during that 3-year period. So that's really cool. It looks like there is a specificity of adaptation to this specific effect, but that was just one. And Jason had already mentioned bilingualism existing on a continuum has potentially a lot of deterministic aspects to its neurocognitive outcomes. So what we're going to do in these next couple of studies is talk about what happens when you examine multiple experiences and how the brain might adapt to these respectively. So we're going to look at specific effects of several experience-based factors. First of all, on the sort of brain structure adaptation, and then on brain function and behavior. Similarly to the last study, we're looking at bilingual adults living in the UK, all of whom have a large variation of language experience across them. First one, as I mentioned, we're going to talk about the sort of brain structural adaptations, and then the next one we're going to talk about sort of brain recruitment patterns with a flanker task. For the analysis, we are going to look at sort of 2 models that we've run that break down experience into 2 general domains: duration of use and extent of use. Duration of use, we use 2 factors, their second language age of acquisition and their length of immersion, the participants prior to their point of testing. For extent of use, we wanted to use, derive some meaning from factor scores that we can pull from this language and social background questionnaire, which is a very detailed questionnaire that documents language use, both in childhood and through to the present day in a variety of settings, both in the home and community. This allows the questions from it can be entered into factor scores, which can give a general measure of non-native use in social and community settings and in the home setting. So basically quantifying what is a very qualitative experience and giving composite scores that can give indications of this. Now, what did we find for the results? Kind of very pleasingly, we actually found some overlapping results in a way, with the immersion study we just talked about. Notably, we see FA values showing a positive correlation with second language acquisition in the corpus callosum. What do we mean by that? FA, when it goes up, implies a restricted directionality of water, and that's basically better white matter structure, if you will, in a general sense. Now, we see that's a positive correlation with age of acquisition, so we've got to remember that actually looks backward. What we're seeing here is the later in life the participants learned the language, the more white matter microstructure they had in that specific region up towards the front of the brain in a tract that connects homologous regions. The idea being that the longer you use it, the less you potentially need that connectivity between those two regions, or it's going back to baseline potentially. Conversely, what we see for extent of use, we actually see gray matter changes in structures that we know are related in language control and processing, like the left caudate. Basically, the more you're engaging with that second language in social and community settings, the more demands post on, and the brain adapts commensurately to handle this. So I'll move on to behavior results. So again, these same participants underwent a flanker task in the scanner. And what we're seeing here is that the task contrasts between condition were all significant. That is, the task did exactly what we would have hoped and expected it to do across all participants. However, these task contrasts were not modulated by the language use factors. And there could be several reasons for this, and I'm happy to field some questions about that if you're interested. However, the flanker effect is just one example of the adaptation, so incongruent against congruent trials, was found to be predicted in terms of the participants' brain recruitment processes to handle these. And again, we're seeing kind of an overlap in brain recruitment as we were to brain structure. Notably, these sort of duration-based predictors show adaptations towards increased efficiency in terms of where the brain is or isn't recruited. Conversely, those predictors towards extent of use seem to show adaptations towards handling those increased control demands, and this seems to have a knock-on effect to domain general cognition. So what can we take from this sort of studies that we present to you so far before I turn the floor over to Tom's? First of all, it seems that individual differences in language experiences do predict to and correlate with brain adaptation. And moreover, this isn't random. The duration of use seems to be related to adaptations towards that idea of efficiency in language and executive control. Extent of use, at least so far, and what we found, seems to be correlated to adaptations towards handling those increased control demands. The degree of adaptation, I should mention as well, seems to be calibrated to the degree of experiences. And going forward, we'd like to maybe also look at how these experience outcomes might actually modulate one another. Now, this is, of course, what we've talked about so far is evidence from younger adult populations. And now I'm going to turn the floor over to Tom's, who's going to talk about how these experiences might interact with aging.
Hey, hello, everyone. So thank you, Vince, for handing this over. What I focus on, what I find really exciting is, what kind of effects bilingualism has on neurocognition in the older age. And in particular, I'm very fascinated by the potential health effects that it might have. This research will be kind of focused more on the health aspect of cognitive aging and bilingualism. The core kind of finding in the literature that we've seen so far is that bilingualism delays the onset of dementia symptoms. So there are multiple studies now that have found this to be the case, and usually this delay tends to be about 4 to 5 years between monolinguals and otherwise matched bilinguals. And to me, that seems like a very significant number that increases the kind of length of healthy healthy life in the older age. And this is thought to happen through two mechanisms of reserve: cognitive reserve and neural reserve. Let me maybe start with neural reserve first. So this pertains to the neurostructural changes that Vince was talking about earlier in the presentation. And it is then seen in the older age that bilinguals would have this kind of progressive reinforcement of the brain. And this comes about in patterns of increased gray matter volume or greater gray matter volume, greater white matter integrity, and then greater structural connectivity in general. And this is something that is thought to be built up over the years of life, and this can actually be measured by comparing different anatomical brain scans. Now, cognitive reserve, on the other hand, this is more of a theoretical construct, and this refers to the building up of a compensatory cognitive ability in the presence of neurodegeneration, meaning that there's no one-to-one mapping between brain and cognitive outcomes or cognitive status. And there seems to be some kind of compensation where if you may see neural degeneration in one's brain, it might not always be the case that their cognitive status would be impeded to what would be expected. So there's this some kind of compensation. And by no means these reserve mechanisms are unique to bilingualism. They have been reported to other lifestyle factors as well, such as higher education, occupational attainment, also physical exercise. But bilingualism has now increasingly been associated with increases in both of these reserve mechanisms as well. And so in terms of bilingualism and aging, the literature is not as big or as fast as it is with younger individuals. But what you see is that when it comes to executive functioning, that those who are bilingual may exhibit better executive functioning than healthy age matched monolinguals, which would be kind of nicely mirroring the results found in younger populations. You also see that gray matter, white matter structures are better preserved in aging, and this I'd say is the case for healthy aging. And this in turn contributes to this protection against neurodegeneration more generally. Right, let's step aside from bilingualism for a second. Let's talk about just aging and the brain. So when it comes to aging and the brain, as the time passes, unfortunately, it is the sad reality that there are global reductions in brain volume and structural integrity, and that's just perfectly normal in healthy aging. It's just the passage of life. And along with this, there's some decline in the memory function as well. And I'd like you to recall that, when we talk about one of the most common types of neurodegeneration or Alzheimer's disease, or dementia or Alzheimer's disease, it is primarily known as a disease of memory. And so there's this kind of link there as well. And one of the core structures when it comes to memory is the hippocampus. It is also vulnerable to aging in general. It's vulnerable to healthy aging. And what I mean with that is that although there is this decline in total brain volume and surrounding brain areas, and this is about 0.5% of volume in a year, the hippocampus actually declines much more rapidly, that at a rate of 0.8 to even 2% a year of its volume. And we can see here in this image from O'Shea and colleagues from 2016, that hippocampal volume, sure, it is linked to episodic memory, but it's also linked to working memory, to processing speed, and also to executive functioning as well. So a very core area, or rather, I'd say a very core structure of the brain when it comes to the aspects of cognition that we are interested in. Right, so do we have any evidence that bilingualism has an effect on the hippocampus, or do we know, how do we know that the hippocampus is sensitive to bilingualism? And well, one of the studies was presented just before by Vince. That was the longitudinal study he was talking about. And just by virtue of being immersed in an L2 environment, these younger adults exhibited reshaping in their hippocampus. And we also see that the hippocampus is affected by bilingualism in terms of very highly immersive language learning. And there are a couple of studies, one by Mortensen and colleagues from 2012, where a highly immersive, very intensive interpreting students undergoing an intense language course tested before and after the course exhibited a significantly increased volume of their hippocampus. So we know that the hippocampus is sensitive to bilingualism. We know that the hippocampus is sensitive to aging, and we also know that there's this link between bilingualism and aging more generally. And this kind of drove the following studies that I will present. The first study is investigating these links in healthy aging, in healthy aging individuals. This has now just been revised and resubmitted, so hopefully we will see this out in print sooner rather than later. The participants in the study were monolingual and bilingual older adults living in the UK in a kind of age range of 48 and above. So mostly the average age was about 62. We collected detailed language background information by the language and social background questionnaire, and we collected memory measures. So we tapped into their episodic memory and working memory using an NIH Toolbox cognition battery, which is an iPad-based testing tool. We also collected their social MRI scans, and with all of this information, we aim to examine and link the kind of behavioral and brain consequences of bilingualism in these healthy aging individuals. And that would be, do we see any volumetric changes in the hippocampus related to their bilingualism? And then do we also see any changes in their kind of behavioral memory outcomes? And then jumping to the results here, what we saw is that if we look at this more conventional monolingual versus bilingual group comparison, we see that bilinguals have a significantly greater hippocampal volume. So in this image, in this figure, we see bilinguals in blue, monolinguals in red, and we see left and right hemisphere. So the hippocampus is a bilateral structure. So there's a left and right hippocampus. So we see that there's this between groups comparison reveals a greater volume in the bilingual group. But also when we regress bilingualism using the composite score calculated via the LSBQ. So when we look at this bilingual experience more as a spectrum, we also see that this is a significant predictor for hippocampal volume. Experiences matter as well. Now, what's interesting on the other hand is that there was no significant effect of bilingualism in any shape or form on behavioral outcomes. In one of these tests, so that we see here the Adambrooks cognitive examination, we see a between groups comparison where the individuals scored at ceiling. We also see no real differences between groups on episodic memory performance, nor on working memory performance either. Right, so yeah, just to sum it up, we do see changes we do see differences on the brain level, but we do not necessarily observe the same differences on behavior, on memory performance. Yeah. Yeah. Sorry.
Tell them they can ask us why.
And of course you can ask us why, and we'll be very happy to give an answer to that question. And moving on to the second study, which was you can think of this somewhat as a follow-up to our healthy individuals study, or study one. We looked at individuals who had a diagnosis of mild cognitive impairment. So what mild cognitive impairment is, it can be characterized as a state on the cusp between healthy aging and dementia. So you see some cognitive decline that is more severe than would be expected for healthy aging, but it's not really severe enough to be warranted a dementia diagnosis in general. So with MCI results, what we see is that they are mixed. There are a few studies out there, but not really a whole lot of literature. And they're mixed in terms of some evidence seems to point towards an interpretation of bilingualism-related brain reserves, some about cognitive reserve. It really is quite an under-researched area as well. We also see that just in line with what we see with Alzheimer's disease, bilingualism also predicts later onset of symptoms. However, progression from mild cognitive impairment to Alzheimer's disease tends to be more rapid in bilinguals, and this might be a result of these exhausted reserves as the time passes. And we wanted to tap into the same areas and see if we can see the same effects or if there's any changes in terms of these reserves, especially on memory and the hippocampus in MCI patients. So for this study, 38 bilingual participants were recruited for this study. All of them patients with amnestic mild cognitive impairment. All of them were Spanish Catalan speakers residing in Catalonia. And that's why I'm saying they're 38 bilingual patients, because they all knew Spanish and Catalan. However, some of them only used Spanish in their everyday life, while others used both Spanish and Catalan. And so the way to determine their engagement in using both languages is there were two factors we looked at. We looked at their self-reported Catalan fluency. That is, it is reasonable to assume if one is fluent in Catalan, then of course they've had the opportunities for engagement, and also their self-reported bilingual engagement, which is how much time they spend in each language context. Similar to before, we also had a neuropsychological testing battery that was focused on episodic memory, and structural MRI scans were required with a 3 Tesla scanner. And as I said, this is still in preparation, so the results are a bit rough around the edges. But what we find was that, first of all, active bilingualism is proxied by Catalan fluency, predicts significantly the later onset of MCI symptoms. That it's interesting is that it did not predict later onset, later MCI diagnosis, just the symptoms. And I'm finding trouble with this. Okay. And also, we saw that active bilingualism was associated with increased hippocampal volume, but this time only in the right hippocampus, not bilaterally. And as was the case with our previous study, we didn't see any effects of bilingualism on their memory performance at all. So to summarize both of these studies is we see that active engagement in bilingual language use will contribute to improved outcomes in the older age. The results show that the hippocampus seems to be protected, which given the type of symptoms you see for dementia could be a potential aspect in delayed dementia onset. However, this volume differences were not linked to differentiating episodic memory performance, nor in healthy aging, nor MCI. So the clinical implications of bilingualism might be more general, but this remains an empirical question, right? And with that in mind, I'd give the floor back to Vince to talk about a study that both him and I are doing together on the kind of bilingual effects across the lifespan. Thank you.
Thanks, Toms. So now that we've sort of presented kind of evidence for the, say, younger side of the house and potentially older side of the house, what we have noticed in the literature is that there seems to be kind of a gap for the sort of middle age, this preclinical status, if you will, and what happens in this age and why that might be meaningful to capture that, to know what's going to happen potentially later in life, like how bilingual engagement in middle age predicts potentially aging accounts down the line. It's especially true when we're trying to not just account for the traditional bilingual to monolingual comparison, but account for these different experience. So our knowledge of how the degree of bilingual engagement modulates this nature trajectory across such age groups is pretty limited. So what we're doing here is taking a slightly wider age range and looking at how bilingualism might affect the trajectory of white matter decline in aging, and how varying degrees of bilingual experience might ameliorate the nature and rate of this trajectory. So we're looking at data from a cohort of bilingual and monolingual adults, as I mentioned, fairly wide age range, primarily looking at their white matter structure, specifically some mean diffusivity and FA values, which I touched on before. What we'd expect with aging, just as a quick aside, MD should go up, FA should go down. And that'll be kind of important to bear in mind as we present the results. We're looking at these data from both a whole brain perspective as kind of an indication of whole brain health, and then some specific regions and tracts of interest, which we know from previous literature have been implicated in both bilingual language control, but also age-related decline. Again, use the LSBQ to extract some meaningful language experience measures from these participants. And we're looking at two analyses for this. First of all, a set of general additive models run on a matched sample of older bi and monolinguals, and then some linear models run on the entire data set, looking at interaction effects of age and bilingual experiences. So generally speaking, what is it that we're finding? For the GAM analysis, so looking at the sort of trajectory of aging between groups, what we ended up finding was an effect of age in the right superior longitudinal fasciculus, a tract that we know is involved in connecting regions associated with language and cognitive control. And we see a general effect of age, significantly so downwards for monolinguals, but that doesn't survive for bilinguals. Now that suggests to us that the white matter integrity is deteriorating across this trajectory a little more rapidly for the monolingual individuals. Following this up with the sort of individual differences analysis, what we're seeing is kind of a really interesting thing, that in several tracks, but notably the whole brain MD values I'll highlight here, seem to show this interaction between degree of bilingualism and age. So what that is that the more engaged with bilingualism one is through the lifespan, the flatter that curve becomes, which indicates to us that greater engagement with the language is correlating to a slower decline with white matter integrity and age, giving this idea that it's not just about bilingualism bolstering this sort of neural reserve, it's also about the degree to which you engage with these relevant experiences. So last bit, we're going to turn the floor over to Jason, who's going to talk about where we potentially are going to want to go from here.
Okay, thanks. So let me say, first of all, thanks for them doing this really great job of summarizing things. Hopefully it's not too much information. This will just be a minute or two, but we wanted to talk about where work within the neurocognition and bilingualism theme within Aqua Aurora, and in particular our lab, is going. And we're particularly interested in cognitive aging, not least because of its practical functional value, okay? Okay, so I'm just going to tell you a little bit about a grant project that we put together with really an amazing, wonderful team of people from several countries and from actually several departments here at UIT. So this involves people both in psychology and clinical medicine, which is fantastic. And the grant is called CABI, so Cognitive Aging and Bilingual Experience Effects. So here we're trying to understand a comprehensive examination of bilingualism as a lifestyle factor, right? The potential lifestyle enrichment factor like education and physical activity that give rise to as potential accruers of this cognitive and brain reserve. We want to understand how this contributes to an amelioration effects related to normal and eventually pathological cognitive aging. So, just in terms of the normal trajectory and then people who are patients. We want to really understand bilingualism as an independent factor feeding into cognitive and/or brain reserves as seen in the latter years. And by independent factor, I want to stress this, as I believe Tom said, and probably all of us, other factors are, of course, important. And all of these probably proxy for opportunities, cognitively demanding tasks that over time give rise to cerebrovascular improvement because of the involvement of physical activity, right? I mean, as the brain is working, there is a physical realization to all of this juggling that it's doing. We are looking to test people who have recently retired, and this would be a quite novel approach. And the reason is because we, especially in Norway, but in other contexts, we have a real potential here for shifts in engagement with bilingualism. Because it will have peaked and potential disengagement at an individual level will set in. That'll also help us to understand the temporality of these effects and the, we see that there are effects, but people in most studies continue to be bilingual or have, we're looking at a snapshot. What we want to do is kind of understand this across time, but at time where people would disengage. So to unpack this, let me just explain to you, many of my colleagues are sound almost like I do, or some of them even sound completely native to my ear when they speak English. They spend a lot of time, because our group is very large here, English is the lingua franca. The minority of people here are actually Norwegian. So I know that some of my colleagues use English literally on a daily basis, but maybe when they retire, they won't have a need to do that anymore. And this would be different than bilinguals in other contexts, say Catalonia, where Spanish and Catalan, it might shift depending on work environments, but maybe not so much, or maybe even less so in the context of the United States for Spanish-English bilinguals, where there is a real societal use of both of those languages, and it's not unjust or relegated to specific contexts that might change once people retire. So the idea here is to track this over time. We will use a core battery. I won't bother you too much about it. It's the same type of core battery that we've used, but we will really focus now on demographic measures, diet, education, exercise, social networks, so that we can really isolate bilingualism independently from these other factors that we have to, that much work kind of assumes doesn't change because it's longitudinal in nature over short periods of time, or are just nuisance variables that coexist, right? So we want to measure these things so we can regress them out and get independent value of bilingualism. We're looking at doing 4 very large work packages. It seems like it's not much when you see it in writing, but it really is quite a bit. First, we want to look at cognitive aging outcomes of bilingual engagement and motivations for maintenance. So this will be a behavioral study, longitudinal in nature, tracking people from the time of their retirement over up to 5 years, depending on resources. We want to look at bilingualism and neurophysiological decline. So this actually would be continuing some of the research that we just showed you. So in particular, the first study that Vince went over, following up with individuals past 3 years and looking at themselves, and this is to Laura's first question, but I'll get to it when she asks it, looking at themselves as their actual controls, right? We're comparing an individual's brain to an individual's brain to an individual's brain over time, right? Bilingual experience and functional connectivity. And here we'll make use of resting state EEG. You can ask me about that if you'd like, but it's using EEG to look at functional connectivity, in particular, looking at both a spectral analysis in the different in the different waveforms, but then also looking at primarily functional connectivity via coherence, mean coherence, and that gives you a really good indication. And of course, mean coherence is something within the aging literature is shown to correlate with cognitive and brain reserve, or in particular cognitive reserve. And then language learning finally as an intervention. So looking at language learning in an older age and plotting, again, the control would be their individual self, much like the Mortensen study, but now doing this with older age individuals to see, well, in an older age, at the age of 65 or retirement, do you have the capacity with intervention to accrue a new or maintain brain and cognitive reserve? Okay, let me just give you some take-home messages and we'll get to your questions. Bilingualism is a multifaceted experience with a range of outcomes, not least neurocognitive ones. The nature and degree of outcomes in the brain seems to be calibrated to the nature and degree of the experience. So bilingualism per se does not afford X, Y, or Z, but certain constellations of the experiences of bilingualism that proxy for the engagement or juggling of multiple languages seems to be calibrated, and the degree to that seems to be calibrated to these neurocognitive outcomes and neuroanatomical adaptations. These experiences might also affect the nature and the trajectory of neurodegeneration with aging, and we're really interested in that because of the health practical value of it. And future work attempting to better understand or harness these experiences as a way to ameliorate aging effects is really the focus of what CABI and some directions that we would like to take within within our theme in Akva Aurora. Of course, all of this is a team effort, all of these studies. This is just not maybe even an exhaustive list. So apologies for anybody who's not included, but all of these studies have been undertaken with lots of people involved in different locations and of course in our own universities. And then we just want to thank you. And finally, just tell you, well, thank you. There's two thank you slides, but also if you're interested in our work at all, please add us on Twitter. That's new to me. I find these things weird, and but you know, I guess I'm at that cusp of age where it's a little weird. But anyway, you know, you can follow us at polar_lab, and of course, please, the center which we represent. This is one fraction of the amazing research that's coming out of the Akva Aurora Center, more linguistically focused and looking at various things within bilingualism, language processing, language acquisition across the lifespan is coming out. So please add Akva_Aurora as well, and you can keep updated. So we will now entertain any questions you all might have.